just kind of a neighborhood organization that anybody's welcome to take part in. It's good ideas. We're here to support that. So yeah, MGE is here tonight. Dave had the good idea to put this on to the residents, and he'll introduce Laura. So thanks to her for coming out.
Great.
I'm excited.
Great. Thank you, Nate and Katie, wherever Katie is. My name is Dave Benferrato. I know a lot of you. I'm the former president, the village president before John Irish. And I used to gather in this room fairly routinely. My day job is with Madison Gas and Electric. And we're here tonight. I'm here with my colleague, Laura, to help you spend less money on energy. And there are a lot of different ways to do that. And that lot of good ways to do that just became a little more complicated, but much more worthwhile with the federal incentives that Laura is going to talk about. And you're going to see a lot of information on this slideshow tonight. And before we get going with that, what would help Laura and me for a lesser degree would be to, what would you like to walk out of the room tonight knowing that you had questions about coming in? Or do you have a burning question about something in your house regarding energy efficiency that you want to do a dive into? What are you here to learn tonight? There and then there.
One question that occurred to me, when you buy a car and the tires have ratings on them and all the lettering numbers mean something, is there a similar code for windows?
Okay, I'm gonna write that down.
Yeah.
Windows. And this is going to be the parking lot of issues. So I think Laura talks about windows a little bit during her presentation, and she will get to that. And then you have.
I'm also curious about windows, because we put in windows this year, and I don't know if I apply for credits or not, so how to go about that process.
All right.
I was also curious to know what, I've heard a lot of talk about MGE's replacing a lot of the overhead lines, and I'm kind of curious where that's in.
And I have a hand up with you.
Yeah, I looked through that didn't have any information I wanted.
We can talk offline.
Okay.
Yeah. But I'm gonna put down
Rebates for windows every year.
I'm gonna call that the electric upgrade project.
Oh, that's it, yeah.
All right, what else?
I know Wisconsin just was one of the first states approved for the two different rebates for home
Home,
ceiling and then
here.
also, yeah.
Appliances.
So people who are in the market for appliances may find that useful.
Question about electric cars and, rates and, are they good for the environment? Because we're not using gas, but then we're still burning things to get the electricity. So how does that fall out? I guess
Okay. Anybody else?
Trying to figure out how much electricity things will really use, like if I get a heat pump or heat pump water heater or heat pump clothes dryer. Is that Energy Star number very accurate?
I'm gonna use the acronym ASHP, air source heat pump.
By electrical upgrades, do you mean underground?
That was his question. MGE is in the midst of a big upgrade of the entire grid for Shorewood Hills.
Well, I wanted to know who's gonna pay for that.
Right now, MGE is paying for it, which means ratepayers are paying for it.
Yeah.
All ratepayers,
Yes,
those that get it, or even those who don't?
well, in answer to that, MGE is taking what is a very old grid that is serving the village of Shorewood Hills. And we're upgrading it to a higher voltage, the entire system. And while we're doing that, we're undergrounding certain portions.
Yeah, but not all houses are getting underground.
You still have to pay to hook up. You have a choice, like, it'll come off the pole unless you pay the money yourself to have it go underground all the way to your house. That's your option. That's my understanding.
That his answer is correct. Do you want the service to your house undergrounded?
I'd rather have that, rather than have trees fall down.
Then the service from the transformer to your house can be undergrounded at your cost.
That's roughly 2,500.
Yeah.
But I don't think so. They were not going to go down Oakland.
It's only certain areas of the bill.
So I just had this done, but they go underground from wherever your pole, you have a pole that feeds your house right now. Wherever that pole is, they'll run the line straight down the pole and they'll underground from there all the way to your house. So wherever that pole is, that's where it's going.
I see. Cause he just told me today that the two houses, one on Black Hawk and then one in on Oakway, would have the pole and we would have to have wires, but they weren't going to go.
I would trust your conversation with Zana.
Okay,
Yeah.
and why is that? Why isn't everybody getting that? I mean, why are only certain houses are not open or, you know?
Getting what?
Yeah, the underground.
That's an established longtime MGE policy,
Okay,
that if you want underground service to your house, you can do that, but at your cost.
I see, okay.
Any other topics? Okay, if they come up during the presentation, Laura, how would you like to handle that?
If you have questions today, remember them and we'll cover them at the end because I have a lot of things to cover. And I love answering questions, but that would also get us off on tangents. And normally I love tangents, but I have so much good information to share with you all that I want to get through it.
Okay.
And the beauty is MGE allows myself and Dave to talk with you at length during our work days any other time. So I'm not disappearing.
Right.
I'm here right now and I will talk to you for as long as you want to talk about your specific question. But maybe that would be over the phone tomorrow or Friday or next week. So I'll try to answer everybody's
Right.
questions, but so we'll go that way.
Okay. Any other big picture questions people are wanting to know about? You want to walk out of the room knowing that they didn't know already?
I just want the big picture.
The big picture. Laura is very good about the big picture.
I mean, I've got an old inefficient house, and so I need to know where to start.
Where to start?
Love it. And Dave, questions on EVs,
Yep.
real specific ones. We'll keep those for you since you're like the EV
Yes.
specialist.
Yes. At the right time in your presentation, queuing up.
Okay, great.
All right. So where to start? Where to start? Windows, electric upgrade. We've kind of, I'm going to say we've covered that. If anybody has any questions offline about the electric upgrade project, just come hit me over there. The homes here rebates, electric vehicle questions, air source heat pump costs and use. Any other questions, topics? All right. So with that, I'm going to introduce my colleague Laura Paparaki. And Laura is an accomplished home energy expert. This is what she does day in and day out. You can read her bio there. She's been with MGE since 2018. She got her degree from UW-Madison in civil and environmental engineering. She's worked at various businesses. She's owned her own business, which was targeted at home energy efficiency improvements. So with that, I'm going to turn it right over to Laura. And
Yes, thanks, Dave. And thank you everybody for coming. I'm super excited today. I do tend to talk fast sometimes. We do have a lot to cover. But I'm really excited to present today because there's a lot of good information that's new in the energy world. And for a lot of years, there wasn't that much new information. It was kind of like the same thing over and over, but we've got new technology, we've got new rebates. And honestly, it's never been a more exciting time than right now to think about improving the efficiency of your home. That being said, you know, I always wonder when somebody is standing in front of me, like, why should I trust them? Who are they? What's their background? As Dave said, I've been steeped in energy efficiency, but I didn't just stand and give presentations. For 12 years, I climbed in people's attics, I climbed in people's crawl spaces, I was on construction sites, I performance tested homes doing blower doors and infrared camera scans. I worked with contractors, builders, architects, subcontractors to understand how to build homes more efficiently and how to retrofit homes more efficiently. I did a ton of energy modeling to understand how the different upgrades can help save. And so I'd like to say that I do pull from a really robust background, and I'm very excited to share that with you today. I do have to give a shout out to, it's National Daughter Day. I never really cared about national holidays. I just was like, what, you know, these special days, but I do have 2 daughters. So I would just like to say that I got my act together and it was on my calendar, and I did tell both of my daughters I love them very much today. You might want to consider doing the same. So like Dave said, we're going to talk about home upgrades. We're going to talk about behaviors, like what can you do like once you get everything done to the house. We're going to talk about solar. We're going to talk about EVs a little bit. The most exciting thing is electrification, and that'll be towards the end. And then we'll go over the rebates and tax credits and what this means for you, and that I'm most excited about. So I'm going to get through this beginning stuff. And remember, if you have a question, just write it down. So one of the most important things, and the things I loved to do when I was an energy auditor, was help people have a very intentional journey with their energy use and their homes. And what I mean by this is, you know, doing things in a strategic way so you get the most out of your improvements and you're doing them in the right order. All too often, I would show up and do an energy audit, and people were so excited to tell me, like when I was setting up the blower door, raise your hand if you know what a blower door is. Okay, for those of you that don't, it's a big temporary door with a huge fan in it that allows you to kind of aggravate leaks in the house to identify them. So I would be setting it up, and they would be telling me like how happy they were. They just had all their windows replaced and they're sure they're going to be so airtight. And yeah, the windows were airtight, but then I would tell them you have no insulation in your sidewalls. You have like half the insulation you need in your attic, and like the other parts of your home need this, right? And knowing they spent thousands of dollars on windows, my heart always broke a little bit, because I knew that all those thousands of dollars should have gone into their sidewalls, air sealing their attic, and some other improvements we're going to talk about. And this is what I'm talking about. You have leaving today with the information you need to feel empowered to make the right decisions for your home. Or at least where to start. And sometimes that's with an energy audit, but still. So, you know, once you make that house efficient and you're interested in renewables, go for it. You know, people want solar on their roof, not a problem, but we always say use energy efficiently first, then bring on the renewables. And then, you know, after that, you know, then you start thinking about electrification. And then of course, EVs kind of fit wherever they can into your journey, right? That doesn't have to be done in a specific manner. One of the most important things is for us just to get this basic understanding of like what uses the most energy. When you know what uses the most energy, you know where you're going to get the most bang for your buck. And I love this pie chart because it clearly shows you that heating and cooling are just about half of what we pay, or what we pay and the energy that we use. So where would be the 2 most important things to focus on? Heating and cooling. And then water heating following that. So knowing that, right, and being empowered by that, we're going to talk about your homes, what's going on inside them, and what you can do to that house to reduce your heating and cooling load. All right. We all know you can turn your thermostat down, right? But we all know that would make the majority of us uncomfortable, and we don't like that. So right now, this next part of the presentation, we're going to talk about all the things that are going on inside the home. And I am an engineer, so I do like to force people to like go back a little bit to their science brains and ask the audience, can anybody tell me one of the 3 types of energy transfer? Conductive, yes, conductive, conduction, convective, convection. Starts with an R.
Radiator.
Radiate, okay, yes, very good. So what are these? Convection, and we just use the fire as a really like practical example. That's the heat coming up off of the fire. Conduction is actually moving heat through a material. And then radiation is electromagnetic waves. Now, the reason why this is important is because, you know, energy is neither created nor destroyed, right? So I always used to ask myself, you know, like what's going on in our homes? Why can't we just heat them and have the heat stay in? Like, how does that work? Why do we constantly have to heat them? And it's because of convection, convective losses. That's air moving in and out of our homes. Conduction is just heat moving through the drywall, moving up through the attic, moving down through the basement, and then radiation, which we don't talk as much about. But these are basic just laws of how energy moves. And it's important to just kind of understand and know because this is how we then know how to remedy. So convective losses, this is air movement. One of the most important and overlooked improvements in homes always, even brand new homes built today. So somebody tell me, why does heated air, okay, not just stay in the house? Why can't we just run the furnace? And then why doesn't it just stay there? What forces are happening on a house that make the air move in and out of the house?
It wants to be free.
It does want to be free. Yes. Like, warm will always move to cold, right? And that is like those molecules wanting to be free and chill out, in my opinion, you know, on a tropical beach someplace. But anything else? Like what's happening to a home when we're inside of it that would force the air to move in and out?
Going in and out of your house.
Sure, yeah, like that. What about with the wind? Yes, we cannot control the wind, but the wind definitely blows on our house and actually forces air movement.
Also, anytime you're burning something that you're combusting something that takes air and creates a vacuum inside your house.
Yes, yes. And what else do we use in our homes that intentionally throws air out of the house on purpose? Fans. Can somebody tell me which thing in their house right now throws the most amount of air out of the house, likely? Maybe, but
Dryer.
the dryer. A bath fan will throw about 80 CFM out. A dryer is 400, and we never think about it. We never think about that. But so why doesn't air just stay in our homes? Because the wind blows on it, things are combusted, we turn on fans, and the most important, because we can't control the wind, right? We can plant trees around our house, but for the most part, that wind is always going to blow. We can't control really the combustion and the ventilation because we need to ventilate our homes. But the one of all of these that we can control is stack effect. Stack effect is, you know, based off of the idea of a chimney. You create warm air and that rises and goes up and out of the chimney. The problem is that in homes, we're doing the same thing. We are creating warm air and it will rise and it will leave any way it can because it wants to be free. And it happens all the time. And when I would show up in homes and I would set up a blower door, which is a way to temporarily find these leaks and do an infrared camera scan, people would be amazed what do you mean my house is leaking all the time? It's like, well, 24 hours a day, 7 days a week in winter, or when it's colder outside than inside, warm air rises, it leaves through nooks and crannies, and cold air comes in down low because there's always the same amount of volume of air in your house. So if any leaves, some must come in. And if that stuff that comes in is 0 degrees because it's winter, you're gonna have to pay to heat it. And the interesting fact about all this leakage is that we mercilessly beat up windows and doors. Oh, they're so leaky. I would show up for an energy audit. People say, oh, I know you're going to find our windows are so leaky and horrible, right? Because we interact with them. But look, window leakage is a very small part of what is typically leaking in a house. All of this other leakage, floors, walls, ceilings, plumbing holes, that's like almost 50%, okay? We don't even think about it. It's happening all the time, and we don't even think about it. They say on average, and this is very average, that if you added up all the leakage, if you added up all that leakage going on in these other areas, it would be like a 16 by 16 inch window or hole in your wall all the time. Think about that. If you walked into your house and in your living room wall, there was a hole to the outside and air was just coming in and coming out all day long, would you fix it? You would fix it. But because we don't see these leaks, because these leaks are hidden from us, we aren't even thinking about it. We're thinking about how leaky our doors and windows are. And those doors and windows aren't even the biggest part of the picture. So how do the leaks get there? Simple things like walk upstairs and attic hatches, notorious. Any chimney will have a huge void around it, typically because they didn't want insulation touching that for fire code. Okay, but materials have changed, approaches have changed, but any chimney. I used to be able to go into attics, clear insulation and things away from a chimney and look straight down to somebody's basement and sometimes talk to them. What that means is warm air all the time was rising around that chimney and going up into the attic. Plumbing, they mentioned plumbing holes, but anytime the plumber puts in, any kind of retrofits, things like that, in new construction, they're usually remedied. But anytime a subcontractor drills a hole to run a pipe, to run a wire, unless they fill it back up with caulk or foam, you now have another penetration in your house. Sometimes walls, like adjoining walls in condos, will just have a big gap in between them that subcontractors did not even seal up. Electricians love to drill a hole to fit the tiny wire in, and then that never gets sealed up. And if you think that doesn't leak, have a blower door and an infrared camera scan, because every time there was an outlet, even on an interior wall, and I did a blower door, there'd be a big dark streak of cold air if it was in the winter coming down there. Because even our interior walls leak. Everything leaks. Anything above our head that has a hole in it will leak. If you live in a Cape Cod or like a bungalow, lots of times these attic areas will be improperly air sealed. Dropped soffits, notorious areas of leakage, never were framed right, usually contributing to massive amounts of leakage. I know, I bought a 1950s ranch in Monona, and I spent a lot of time retrofitting this house, and it was leakier than a cob when I bought it. Somebody puts in a microwave and wants to vent it, and the subcontractor cuts the hole to run the venting. Well, I'm so glad they actually put in venting. But up in the attic, that's just a big bypass. That's gonna let warm air rise and escape. Because, you know, usually that venting is in a cabinet that's hidden. You open it up, you see the vent, you know, you see the vent going up. Well, unless that's sealed around there. So that's how they get there, right? These are all things that every house has. So how do these leaks get remedied? Air sealing. It's something called air sealing. Oftentimes, if you ask a contractor to come in, you will get what's called an attic air sealing package. And the reason why is because all of the warm air rises. And so a lot of these penetrations where you seal them is up in the attic, right? That warm air rises and then it stops. If you've sealed the attic, if you sealed it in the attic. So here's a picture of that same similar chimney flue, but you can use flashing, you can use fire rated caulk, and you can make those areas airtight. Here's a picture of a attic that's been completely cleared out. All the tops of walls, all the exhaust fans, any other like penetration has been foamed over. All that white stuff is foam that actually is airtight. Here's another retrofit. The foam is not as thick. They just did it on their own, but the tops of every wall, every hole that's drilled, it's like hermetically sealing the attic. Here's somebody putting boxes around can lights. Can lights are notoriously leaky. And even small things like electrical boxes and the holes in them will contribute to leakage unless you remedy all that. So air sealing, hands down, almost every energy audit was the best return on investment when I energy modeled. And so it should be the top on everyone's list. If you have not had your attic air sealed, adding insulation does not air seal your attic. Foam and caulk and impermeable materials air seal your attic. Adding more insulation does not air seal your attic. Air moving through attic insulation decreases the ability for that insulation to do its job. So the number one thing people need to do is air seal their attic. You seal that attic and the warm air doesn't rise and get out. And so cold air doesn't come in down low. So that we covered, like how to make your house airtight. And there's a few other ways too. Yes, changing out doors and windows. I'll touch upon one other way here in the insulation section. But that really was your convective losses. This is conductive. This is energy now this is heat and energy just moving through things, okay? And it's really dependent on the amount of insulation you have, the area, right? I mean, the larger the area, the more like heat loss you can have through that area. And then there needs to be a difference in temperature in order to have heat loss through conductivity. So how do you remedy this? Insulation. Insulation will resist the flow of heat. So those conductive losses, this is how we do it. We add insulation. And while warm air rises, so we talk a lot about stopping that air movement by air sealing above our heads, just heat in and of itself flows equally in all directions, okay? So then why don't we put the same amount of insulation on every exterior surface in our homes? Like just stop for a second and think about your house. Everybody remembers the Pink Panther rolling out, you know, the fiberglass, and it seems like attics get all this insulation. Like, why is that? Is anybody, like, if it's about how much surface area, like usually the attic is the same as like the floor in our basements. So we insulate attics to like R50. Why don't we talk about insulating, slab floors? The area is the same. Heat moves through all areas. I just like people to start thinking. Does anybody have any ideas? Why in Wisconsin why don't we put R50 underneath the slab? Where are our slabs? Where are our basement floors? Typically in Wisconsin. Underground. How far underground? How deep? 10, 8, 7? Can anybody tell me what the temperature, the ground temperature is at that place? It's consistent, whatever it is. It stays consistent. So remember when we go back and we talk about when you have heat loss, you need a temperature change. We don't put as much insulation underneath our slab because there's not a huge temperature change. In an attic, you know, you can have the house right below be 70 degrees and that attic can be like -10. It'll be whatever it is outside. So I just like people to start thinking like, why do we throw all this money at attics? There's the same amount of heat loss potentially, you know, happening in these other areas. Some of it is just, you know, practical. If it's 7 feet below grade, you're just not gonna have that much heat loss because you don't have the temperature. Also in retrofits, we just can't get there, right? It's below grade, but if you do build new, we do want to put insulation there. So attics are these usually quite big areas. We just have, I mean, you can sometimes stand in your attic, which means you can clearly blow in, you know, 13, 14, 15, 16 inches of insulation. And that is what we recommend. After you air seal, you do want to insulate to R50 to 60. And I always recommend blown in cellulose versus fiberglass. Another area that we talk that can be insulated is the sill box. Does everybody know what area this is? This is a foundation wall. So we're standing in the basement and we're kind of looking up. These are the floor joists. Sill boxes are the other part of the equation where when that warm air is rising and leaving up high, cold air comes in down low. This is where it comes in. Want to know why? Because so many parts of the puzzle of your house come together there. You've got a rim joist, you've got the sill plate, and while we might think all this thousands of pounds of house sitting on top of these pieces that come together surely must make it airtight. There's no way. It always leaks, even brand new construction. So if you're building a brand new house and your builder and the subcontractor don't put caulk under here, when we do a blower door, that will leak. If that contractor doesn't actually put a bead of caulk underneath that rim board, that will leak. So attention to detail in building new construction is ridiculously important in order to build a really high performance home. And then we buy homes that are old when nobody was even thinking about any of this stuff, right? So what's the best thing to do for sill boxes is to spray foam them. Why? It's because spray foam actually stops air movement, and that is the only type of insulation that will stop air movement. Because I don't want you to misunderstand. I said that in an attic, you can't just add insulation, you know, it won't stop air. That's because we're usually talking about the blown-in cellulose, right? That doesn't stop air. But if you wanted to spray foam your whole attic, it would stop air. But sill boxes are a really good place for spray foam. It's pretty much the only insulation I recommend in the sill box. Okay, foundation walls. Again, if you buy an existing home, there's no way you're going to insulate the outside of the walls. You can insulate the inside of the walls, but oftentimes we don't. Why? Because unless you finish it, right? It's like, well, where do you, if you don't have studs put up, well, how do you insulate? Well, you can, but it's going to look like this. Because you have to cover insulation with a fire rated material. This Dow Thermax happens to be fire rated. So if you did want to insulate your foundation walls, but didn't plan on finishing them, it would look like this. And because our basements are typically below grade, studies have found, right, that every foot you get below grade, the energy loss gets less and less because the deeper you get, the more consistent the temperature is. So the top 4 feet is actually where you're going to get the most bang for your buck when insulating interior foundation walls. Sidewalls. If you live in a house that was constructed before 1950. I did a lot of energy audits that had zilch for insulation in the sidewalls. Shocker, but it's true. And if you don't know, you can have an energy auditor like drill a hole and they will plug it, right? But they'll let you know. But you can actually have your sidewalls dense packed. Sometimes if you have brick exterior, it gets a little harder, but it is possible. And it's dense packed typically with cellulose, that same insulation that's flown into the attic. It's just that they densely pack it. It's literally flowing out of a machine at a specific density, or it reaches a specific density. And so on top of insulating, it does help it does help reduce air movement. It doesn't stop it completely, but it does help reduce it. So windows are another potential improvement, but I show this graph because the only thing I really want to say is, yes, go ahead, improve your windows, but please don't do it because you think you're going to save energy. Do it because they no longer function, the seal is broken, or they're clouding up, or you just, it doesn't open and close as well anymore. Don't do it because of energy savings, because typically most windows, even the best windows, are just always going to be like that weak spot in a home. I mean, even if you get a triple pane window, most walls are R13. The best window is only an R4. So it's like, take that money and first, please make sure the rest of the house is well insulated. Okay, we talked about why air doesn't stay in homes, and it's because, we ventilate and we have fans, and this is a good thing because we want to get moisture out, we want to get cooking particles out, because that then brings in fresh air. So when it comes to improvements, you always want to make sure that your bath fans and your kitchen ranges exhaust to the exterior of the attic and the exterior of the home, and that the ductwork is as straight and short as possible. Sometimes I would go into an attic and I would see like this run like up to the roof, where like they could have just went like straight and short and out like a gable end. So it's good when you have an energy audit to have somebody take a look at that. And then of course, attic ventilation. It is important. We want to stop any moisture from getting up into our attics, and that's what air sealing does. But after that, you got to have the belt and suspenders approach, and that's just making sure your attic ventilates. And vent chutes can help that. If you don't have vent chutes, you want to have those incorporated. Those are like styrofoam or paper chutes that go down into the soffit and then bring the air up. Here you can see in this picture, they've got a vent chute, they've got this fiberglass bat, but oops, look, it's letting the blown in come down into the soffit where the air is supposed to come up. And this is a no-no. So if you are going to have your attic insulated, you talk with a contractor or you have an energy audit, and any of the contractors I recommend are going to know not to do this, but you make sure that when they do that improvement, that they are actually incorporating something that is going to stop that insulation from falling down into your soffit, which would then occlude it and stop it from actually venting the attic. So when I think about all this information and all these different areas to air seal and insulate, I often tell people it's a lot to just navigate on your own as a homeowner. And so I always recommend getting an energy audit. It'll provide a blower door, okay? And it provides a strategic roadmap to understand what parts of your home really can like get more insulation, which ones are going to give you the best return on investment. Has anybody here ever had a blower door done to their house? 1, 2, 3, 4, 5, 6, a few of you. That's great. I love the blower door. One of the best pieces of equipment I used as an energy auditor, because as you can see, it's a big temporary door with a big fan, and that fan, when you turn it on, creates like a 22-mile-per-hour wind on all sides of the house at the same time. Just totally artificial, but incredibly helpful when you're trying to diagnose where are the leaks in this house. So I would use that along with an infrared camera and even a smoke stick to check people's windows to see if they were leaking at all. So that concludes like what you can do to the home itself, just like the shell of the home. And what I love about those home upgrades is once you get them done, it's going to provide you savings, comfort into perpetuity, right? It's not something you have to redo. It's you typically done, you cross it off the list, you're just gonna reap the rewards then. So the next way that we are going to save really comes down to your behavior and then what you bring into the house. And these are the things we know, so I don't spend too much time on them because we all know how hard it is to change our behavior. But nonetheless, the biggest one is controlling the thermostat, right? If the more conservative you are with the temperatures that you have your house at, the lower your bill is gonna be. And the kind of general approach is for every 1 degree for 8 hours, you'll save 1%. It's not, you know, it's not perfect, but it's a great kind of like, you know, is it worth it or what am I saving? And I tell people when you sleep is really, you know, that's eight hours right there where you can turn your thermostat down or up, right, for 5 degrees, that's 5% savings. And then the other things are just common sense, right? Using our shades and our blinds to keep that sun out in the summer, let it in the winter, using fans. I mean, you can run your AC, but maybe put your AC up 1 or 2 degrees and use fans to keep yourself comfortable. Smart thermostats are an awesome way to kind of like buy something and then have it save you energy, but not necessarily have to change your behavior. It will learn your behavior. And we do have the MGE Connect program. Anybody here participate in MGE Connect? If you have a smart thermostat, you can let us temporarily control the temperature of your thermostat on those really like heavy hitting days when the grid's just getting slammed. Okay, it is a nice program. If you are looking ways to help reduce strain on the grid, you do get rewarded for that, $25 a year, and that comes as a bill credit. This I absolutely love. Your house does not care how warm or cold it is. The pipes in the house might, but beyond that, your house is never complaining it's too hot or cold. You are. And so we have this mantra, which is heat the person, not the room. And I'll tell you what, I bought this heated vest and these slippers, and I have never been so happy. Because now that we work remotely and my kids go to school and I'm the only one in the house, I can hardly justify heating my entire house. So I don't. Ask Dave, I'll put on my hat, I'll put on my vest, I'll put on my heated slippers and even my heated vest, and I'll keep my heat down. As crazy as it is, I'm super comfortable. And I'll tell you what, these make awesome Christmas, like holiday gifts. I got these all on Amazon, and the slippers are fantastic. Got them for my mom. She loves them. And if you're like really motivated because like the vest runs on like a portable battery, the slippers have their own portable batteries that you actually recharge. But these portable batteries, did you know that like some of them are even solar? You can charge them from the sun even. And then you just have that portable battery pack, and you can either have on your heated blanket or your heated vest. Why does this make sense? Because not only if you can turn your heat down are you saving, but you know, MGE has, you know, a drum that we beat, and it's like, watch out for that space heater. Because if I can be warm with my slippers and a vest, so this is 8 hours a day. So let's say I'm working at home for 8 hours a day. Those slippers are going to cost me 22 cents for a month for 8 hours a day. That space heater is going to cost me $60. And I see it all the time, you know, people set up their space heater and they're sitting next to it, right? But that space heater is heating that whole area. But that person, you know, is, yes, they might be being kept warm, but like at a price. So can you heat the person and not the room? You sure can. And there's a lot cheaper ways to do it. Other things which we all know, turning off lights, minimizing plug loads, using like smart strips, purchasing Energy Star, checking your water heater. How many of you have ever gotten one of those little cards where you run the hot water and into a cup and then you stick the card in there and it tells you what temperature your water's at? Oh, yes, Dave. So many of us have our water heaters just turned up way too high. You don't need your temperature at anything more than 120. But guess what? You can't go down to your water heater and check to see what temperature the water is. That's not the way water heaters work. You actually have to measure the water coming out of your tap. And so we have a way for you to do that. Then you go back and you adjust your water heater. And then of course we know, so we're talking about, right, we talked about the shell of the house, we're talking about behaviors and products, you know, furnaces, AC and heat pumps, you know, you go with the more efficient ones. And because you're gonna have that, right, for 15 to 20 years. So we covered the house and the upgrades to the shell of that house, right? You cross that off, you work in some of the behavior items and you buy some nice products, maybe a smart strip so that like some of your appliances are being controlled through the smart strip. Maybe you get the heated slippers, but you change your behavior a bit and you're reducing your energy use. And then of course, the next step, once you're super, you know, efficient, is then you start thinking about renewables, right? And I'm going to talk a little bit about options here. So we have our shared solar. It's currently fully subscribed, but we do have a waiting list and we have proposed another to the Public Service Commission. What shared solar is an option for people who may not be able to put solar on their homes. They may choose not to, but they want to support renewable energy. Shared solar is a program where we have local solar fields and you more or less pay an upfront fee that kind of reserves a certain amount of the panels for you. And then typically how the program works is then that energy from those panels is offered to you for a certain amount of time at a set price, right? So like when I signed up for shared solar, it's like, okay, you're gonna get, yes, I had to pay the upfront fee to kind of reserve my panels, and then I'm gonna get that local solar for the time of that contract. So we have proposed another one to the Public Service Commission because it is really popular. I personally, because I'm an MGE customer and employee, I put shared solar together with Green Power Tomorrow, and Green Power Tomorrow is a REC program. So when we use electricity, all the electricity generated all over just gets thrown onto the grid, right? It's not like we have one wire that says like, oh, this is just solar and this is just wind. No, we have big transmission lines and all of that generation gets thrown on the grid. If you want to support renewable energy and you want to claim and say, I know where my energy was generated, you can use our Green Power Tomorrow program, which is RECs. So people who the generators who, you know, MGE who create the renewable energy, for all the renewable energy produced, they get these RECs. And we can either sell them or we can hold them, because RECs really are like a currency of the renewable energy market. It's a real thing, all utilities have them. And we offer them to our customers for a price, it's a penny more per kWh. But when I use my shared solar and my Green Power Tomorrow, we are 100% renewable, because once you buy that REC, it then gets retired and it's claimed as yours. So you have claimed, because every REC says this energy was generated from this windmill and this, you know, like it very specifically says where it's from. And so because we our roof is like mid-age, so like we're not looking to put on solar anytime soon. So those are the ways that we choose to support renewable energy. If you are in the market to put renewables on your roof, I recommend Google's Project Sunroof. I have heard from the word on the street is that this is pretty accurate. That they have taken thermal imaging of everybody's home from satellites, I'm sure. And it'll give you kind of an estimate. Like you put in how much your energy bill is and it'll say like, hey, you need this size system and it will cost you this approximately this amount of money and your payback will be this. And then if you don't want to do any of that, that's okay too, because MGE has a pretty strong, we have a pretty strong goal of by 2030, we expect that all of our customers will be 80%, will have 80% fewer carbon emissions just by being an MGE customer, because we are on a path of net zero carbon by 2050. And we are halfway there. And so we are working to bring on more renewables and to close our coal plants so that our carbon emissions, which, you know, if you're worried about your carbon footprint, we're taking care of that, right? So there are some things that MGE can do, and there are things that our customers can do. And we always say, use energy efficiently, bring on renewables, that's our job, unless you want to do it too, and then electrify everything. And this is our mantra for combating global warming. And so the other thing is, if we can do it, if we can go faster, further with the help of our customers by you being more energy efficient and electrifying, then we will achieve our goals even faster. Clearly, we are bringing on a ton more renewables, and that is why we are certain that by 2030, just by being our customer, you will be using energy that has 80% less carbon emissions. So where are we? So we talked about the home, the improvements, the behavior and products, renewables. So we'll touch a little bit on EVs, which, you know, electric vehicles are kind of like that next electric appliance that we're going to have in our house. And MGE has a number of different programs. Charge at home, where we will put in a charger for you, and then you get a per monthly fee until that's paid off. And then you don't have to deal with the electrician. You know, you don't have to deal with the bill. You just pay. Charge ahead, EV owners group. We have a lot of different public charging stations, and Dave is our EV guru. And so I'm not covering a ton of EV things today, but if you there were some EV questions. Do you want to hop in right now?
Real quick. Does anybody own an EV? What do you own? Sorry, talk to me mouthful.
A Volkswagen, and we did the, I think we did the charger, we had someone come and install.
Charge at home.
Charger.
VW ID4,
Mhm.
good car, that's what I have too.
Mhm.
Anybody else, any other EVs? So, electric vehicles, Laura touched on it. We're moving to a phase of the electrification of everything. And what that involves is decarbonization. And from a transportation perspective, that's why the new BRT buses are electric, because that's one of the moves towards the electrification of the transportation sector. So from a personal standpoint, there are, every automobile manufacturer out there is offering EVs as part of their fleet. If you're at all interested, we have a bunch of these on the table over there. Pick one up. It's a guide. It's a guide from EPRI, the Electric Power Research Institute. It's unfortunately about a year old, The new version is gonna be out any time now. I thought it would be out by now, but it's not. But it's still good, and what's good about it is it gives a little bit of a 101 to what electric vehicles are. And then it gives, the neat thing is it gives a little profile, a picture and a little profile on every single electric vehicle on the market. What the range is, what the manufacturer's suggested retail price is, and so on. I'll just tell you that MGE is all in. We do offer the Charge at Home program. That charging station right there would be mounted in your garage. There'd be a dedicated 240 volt circuit back to your home's electric panel. And you would skip going to the gas station. You wouldn't have to go to the gas station anymore. You would just come home at night, plug it in, and by morning, your car's battery is ready to go. And if you have a VW ID4, depending on the model, you'd have an EPA estimated range of 282 miles on a single charge. So we offer that program. Laura kind of capitalized it. There's a brochure here if you're interested at all on that. We have a few other programs. I'll just tell you from my personal perspective, my wife and I, Carolyn, some of you know my wife, Carolyn, we are down to one car now. And so we have that all electric VW ID4. And like Laura mentioned, Carolyn and I are using 100% renewable electricity at our house through the programs that MGE offer. We're just like Laura's house. We're in the shared solar program. 50% of our power is shared solar. 50% is wind power through the Green Power Tomorrow program. So from those two, we are at 100% renewable electricity at our home. And then we charge our vehicle exclusively at home unless we're on a road trip. So we're driving our vehicle completely on renewable electricity, really lowering our carbon footprint, which was what was important to us. So if you have any questions about EVs, see me afterwards or during or what have you.
Thanks, Dave. And I know we didn't cover windows, but I want to go to some websites about the window questions. So if it's okay, I'm going to cover those in a little bit because we're getting to the part of the presentation where I'm really excited. So I hope the pizza's not totally setting in and you're going into carb comas, but maybe I have to get everybody up and like do a little dance. But okay, so we've covered, use energy efficiently, bring on the renewables. So now it's electrification, right? This is the new stuff. This is the things that we haven't really heard much about it. So I really want to take the time tonight to cover it for folks, and it covers the rebates and whatnot too. So what is electrification? It's really simple. It's just taking things that use natural gas and converting them to electricity. However, the catch is that it uses a new technology, the majority of the new appliances and equipment, and it's heat pump technology. And we're going to get more into what heat pump technology is. I have on here that electrification, okay, is not just about homes. It really started with transportation. And we see this all the time, right? We had internal combustion cars. But it's like, no one even questions, like when somebody gets an EV, it's like, oh yeah, or if somebody says like, I have a hybrid, right? Okay, so we've seen this entire industry, which for eons had internal combustion engines, and none of us right now are even questioning that change. It's like, oh yeah, Dave got an EV, she got an ID4, like it's happening. That industry is changing. Internal combustion engines, right, are still around, they will be, but people are now driving all electric vehicles, and for good reason, because tailpipe emissions account for like 1/3 of all greenhouse gases. So we see that industry changing. That's like real tangible. We get it, right? The next phase is and that's the electrification of transportation. But the next phase is electrification of buildings. So what does that mean? Especially for us that own homes. Well, what uses natural gas in your house? Dryers, water heaters, your furnace, maybe your range and your oven, and a fireplace. So we're going to talk about how these are being converted, okay, to going from using natural gas to using electricity, but using heat pump technology to make it more efficient. They say that heat pump technology is 300% efficient. Like, I'm an engineer. I was like, wait, head scratching. How does that work? How can you put like 1 watt in and get out 3 to 5? Sometimes they say it can even be more than 300% efficient. Yeah, is it magic? No, it's refrigerants and thermodynamics. Refrigerants changed the world. In the 1920s, Freon was created, and people didn't have to have a chunk of ice sitting in their ice box and have it delivered. The refrigerator was invented, and it was safely invented using Freon. And Freon stayed around to be a refrigerant till even now. So how does it really work? Because all of you are going to leave tonight, and you're going to end up having to make a decision, because your air conditioner is going to die, your furnace is going to die, your water heater might die, your dryer might die, and you're going to say, I remember that one lady from MGE, and she said that I could buy this, but with a heat pump. And then you're going to be like, well, yeah, but I don't know if I really trust that. What's that heat pump stuff all about anyway? And then there's going to be a contractor who wants to replace something for you really quick and really fast. And I'm here to tell you that this is going to be a little interesting, because I'd like to go through this heat pump technology and the science behind it just a little bit to empower you to be able to recognize when somebody says that's heat pump and go, oh, I get that. It's not magic. Somebody's not trying to pull the wool over my eyes. Like, it's actually just science, which, hey, we covered before. Conduction, convection, and radiation. This is the same thing. It's just about heat transfer. So let's just break it down. So I'm going to start at the bottom here, okay? And we're going to work our way up to the top. Refrigerants are a bit magical. We forget what they are and what they do, but we live with them every day. They're in our refrigerators, they're in our air conditioners. But the refrigerants can go from a liquid to a gas and vice versa. And this is their beauty, okay? And when a refrigerant goes through an expansion device, which this happens in your air conditioner, but this will happen in your heat pump when you get one too. And actually, let me take just a step back. Let me ask somebody, let's ask you all. Have you ever been standing outside by your air conditioning unit, you know, the part outside, when it's on? What does it feel like? Is it cold? Is it warm? What kind of air is it blowing?
Hot.
Should be blowing hot air. Where does that hot air come from? The house. We're asking the air conditioner to remove and transfer the heat from our house to the outside. And if we actually went and stood by that very piece of equipment we're asking to do that, we'd feel the hot air coming out. So all that's happening with this heat pump technology is we're taking that outside unit and we're putting it in the house. So that hot air that's blowing, we're just using it to heat the house. We're literally running our air conditioners in reverse. It's not magic. But the reversing valves and the science behind the heat pumps and how much more efficient they've made them and to be able to work in cold climate, that's all tweaking that has made it very possible. So knowing, right, that all this piece of equipment is delivering heat inside your house. It's really that same unit that's sitting outside all of our houses right now, blowing hot air. It's just that, hey, we're going to blow that hot air into our houses and use it to heat us. Anyway, stick with me. So refrigerants are super awesome. You can send them through an expansion valve. And when a gas expands, it gets cooler. And when it gets cooler and you send it outside, that really cool pipe is going to absorb heat, even when it's cold outside, because that refrigerant is so cold that it is going to absorb heat, because warm moves to cold, basic science. So you have this unit sitting outside, you have this refrigerant that just got expanded, it's super cold. There is heat in outside air all the way down to absolute zero. So you can pull heat from the air even when it's -15 out. And that's exactly what happens. The heat transfers to the refrigerant, okay? That refrigerant then moves up and goes through a compressor. And these refrigerants get compressed and the molecules get pushed together. And when that happens, the magic of refrigerant is that they get hot. Don't ask me how that happens. That part I am not, I can't explain all that, but it's all about thermodynamics, right? So now you have this compressor, okay, with this super hot gas. And now it's gonna come into the inside unit of your house and you're gonna blow air over it and you're gonna get that heat, just like it's doing right now outside. We're just reversing it. And when it blows the air over that tube or that coil, that heat is transferring to the house. So now that refrigerant cools down, right? Because it just gave its heat up to the house. Thank goodness, we want it, we'll take it. And then that cooled refrigerant just goes right back and starts the process all over again. And with refrigerants and the law of heat transfer and thermodynamics, this refrigerant just keeps going through the phase changes and just keeps providing us all of this heat and cool. And one thing we don't think about is that when our air conditioners are running, right now we have refrigerants, comes inside the house, it's very cold, and the air blows over it, right? And it provides us with that cold air. But what we don't think about what's happening is that that refrigerant is actually removing heat. We just don't think about it because we're like, yay, our AC is running and we're cold, like we're cool. But what's happening is when that air blows over that refrigerant, it's actually also absorbing heat. It's removing heat. And how do we know that's really truly happening? Because you just said when you go to your outside unit, it's blowing hot air. Well, that came from somewhere. It came from your house. It actually got transferred to the outside. So this excitement over electrification, really, in my opinion, comes down to the beauty of refrigerants and thermodynamics, which is crazy. But it's really awesome because we all like to control our environments and we've got to the point that we can. And so that's how heat pumps work. And they can be used in anything. They can be used in a dryer, right? You have that same refrigerant. It's going to blow the hot air into the drum. It's just then gonna come out and go through the coils where then it's going to get cooled down. The refrigerant's gonna get cooled down. It'll condense out that moisture and then it'll be drained away, right? And then it just goes back and gets compressed and gets hot and then it blows over. So it's that same technology, just put in different equipment. Dryers. The beauty of a heat pump dryer is that it no longer vents to the outside because the heat pump cycle or refrigerant cycle will always end up condensing the moisture. And so that will be drained away. But now we have to send the moisture out of our houses, right? Through the ductwork. No longer will that have to happen. So this actually is extraordinarily awesome for a number of reasons. I would love to have a dryer on my first floor, but can I route the ductwork? I don't know. But with a heat pump dryer, I can do that now. Yes, I have to be able to have a drain, but like usually that's doable, right? And so you'll be able to put dryers in places where you haven't been able to do that before. And if you have an electric dryer, it's going to be much more efficient to go to a heat pump dryer. I haven't modeled the energy savings. Somebody asked me that, or somebody asked that about these different appliances. The dryer I'm not positive about, but the heat pump water heater, again, same technology. That heat pump cycle is happening. It's taking inside air from your basement or wherever you have your water heater, and it's transferring that heat down to the water, and then it's blowing cool air out. And in the meantime, again, because anytime you have this cycle, you're also going to have some condensation, you know, it'll condense. You'll have to have a drain. But the beauty of these is that they also like dehumidify. So wherever they are in the basement, which like in Wisconsin during the summer is great. And so I do know when I model heat pump water heaters that they come out neutral. So like if you have a natural gas water heater right now, you can put in a heat pump water heater and feel confident that you're not going to spend any more money. And if you have an electric water heater, you're going to save a lot of money. Okay, so we said, where does this technology go? Dryers, water heaters, and now the big one for us to wrap our heads around is like heating with it. And even though I talked about it in that example that they do this, like an air conditioner running in reverse, that being said, even though it's super efficient, okay, heating with electricity, even heat pump technology, in comparison to natural gas, can be a little bit more expensive because we come from a time when our natural gas, well, I'll get to that, has been incredibly economical. I mean, like, you sometimes have to take a step back and just ask yourself, like, why is something more expensive? It's because there's something we're comparing it to, right? Somebody's short, somebody's tall, right? Something's black, something's white. Like when we compare as humans, we say, well, this is going to be more expensive, but that's because what we were comparing it to was incredibly cheap. We have like lots of domestic natural gas, but we all know it's coming from fracking, and we all know that needs to potentially end. And this is what electrification is part of, right? And so many people will likely go with what's called a dual fuel route, okay? And what that means is you have a heat pump outside and it works in conjunction with your furnace. So you can keep your furnace, but you let that heat pump heat and cool. They're phenomenally efficient at cooling, way more efficient than just like typical air conditioners. They're really efficient at cooling. So you can use it in like the fall and spring to heat, but then you let that natural gas furnace do the heavy lifting. Now, I will say there are some people, and I'm just showing you what, like, this is an air source heat pump inside unit. It looks just like your furnace because the only thing that's different is the part that sits up here, that A coil. That's the only thing that's different. Otherwise, this is a natural gas furnace. It's just coupled. But the outdoor unit could look different, could look like this. It also could look a lot like your air conditioner. But the idea is that they can heat and cool. Now, there are people in our service territory that have gotten rid of their natural gas and they just use an air source heat pump. Some of them pay more because it's their choice. It aligns with their values. They don't want to be using natural gas anymore. They're willing to pay more. Some people super insulate their homes, and I do know a few people who don't pay any more for heating and cooling with an air source heat pump only, but they have been very diligent about insulating their homes and air sealing their homes. So it is possible. But I do want people to understand that heating with a heat pump only could actually increase your bill. Not astronomically, but like you will pay more. Because even though they're super efficient, natural gas has just been so darn cheap. This is fun. I like to throw this in here. There are furnaces. They are not popular here. They're popular in Minnesota where there are co-ops, but they have ceramic bricks. And you can actually, if you have excess energy, like from renewable or your own renewable, I love this option. I don't know why it doesn't take off more, but the ceramic bricks, you take that extra electricity from your solar, or like if you're on time of use when energy is cheaper, and you heat those bricks up with electricity and you pair it with an air source heat pump, and those bricks can stay heated for up to 24 hours. And so you can heat with that. I mean, that is the original caveman right there, meets modern day human, right? I mean, even cavemen put bricks and stones in the fire and then put them in their sleeping bags to stay warm. This is essentially, you know, that. The last one, it doesn't use heat pump technology, but induction cooktops are kind of like the new wave of the future. They use copper coils to create electromagnetic fields that heat the cookware. And so they're a bit more efficient. But in terms of electrification, so what will it do to my bill? Okay, so like I said, you can do like the heat pump water heater and the heat pump with the furnace and come out about neutral. I've studied people's bills. And remember though, it's only because we're coming out of a time when natural gas is so incredibly dirt cheap. In 2008, that's the last time it was over $1 a therm. And like, the point of this is showing all this is just to say that like it's been really economical. And so we can't say that heat pumps are more expensive. We can only say they're more expensive in comparison to natural gas.
Is that the nominal cost of like that's $1?
This is just the per therm.
2008.
Yep.
So
Well,
that
no,
would
in
be
2008 it was $1.14.
So like nowadays that would be like $2.
Yeah.
If you were to.
Yeah, you use inflation and everything
Yeah.
like that. That was like the actual cost.
So that's the nominal cost. Okay.
Yeah, yep. So I mean, like, the natural gas market's just all over the place, right? But just remember, when we say something's expensive, it's always in comparison to something else. And people don't buy things just because of what they cost. They buy things because it aligns with their values. And Rocky Mountain Institute is a nonprofit whose purpose is to like help transition the global energy system to like a more low carbon clean. They did an article, and you can Google this article. It was specific to Wisconsin, and the question is like there were like a bunch of questions specific to Wisconsin, but the biggest one is, do electric heat pumps actually reduce emissions when we're still using coal in Wisconsin? And the answer is yes, and it didn't come from me, it came from the Rocky Mountain Institute. And you'll see that. And oh my gosh, if you're using electric heat or propane, a heat pump will like annihilate. Like it'll be so much cheaper. So if you know anybody on propane or electric heat, like talk to them about heat pumps. But you can even see over the course of the lifetime of the equipment, because these things last, 15, 20 years, even with today's grid and then proposed changes, it makes sense to go with a heat pump, even if you don't have solar, right? Because our grid's continually getting cleaner. And so people make purchasing decisions, not just because something's cheaper, because if that was the case, no one would shop at Willie Street Co-op or Whole Foods. And like, I've been in both, even though I could go to Woodman's, right? We all have these value propositions, and one of them is the environment. And this pretty much is just my answer to say, you can feel okay buying a heat pump and heating with it, even if you still have your natural gas furnace to do the heavy lifting, and feel like it's the right environmental choice. So now that this is like also awesome and you're like, I get heat pumps and it's a good environmental choice, like I'm here to tell you it gets even better, because you're going to get a lot of rebates and potential tax credits around them. There are 4 main programs. The Inflation Reduction Act created here and homes, and we'll get into each one of those. Focus on Energy is our state. And then there's federal tax credits. And you can see these buckets. The HERE program is by far the biggest. Everybody can get up to $14,000 off of appliances. But let's get into it. They're income based. So I'm gonna give everybody a second right now. They're income based. If you make between 0 and 80% of the area median income, you're gonna see AMI a lot. That just basically means Dane County. And it's all dependent on the number of people in your household. If you make between 0 and this number, you're in this like first income bracket. If you make between this, if you make between this and this, you're kind of in that second income bracket. If you make over this, then you are not eligible for HERE. You're just eligible for homes, and we're gonna get into this, but I want everybody to at least get a general, like, think of your 1040, think of that number on the bottom, right? Where are you? Because we're gonna go through some examples.
That's taxable income, not adjusted gross.
No, it is adjusted, yeah. Or it's, you know what, don't quote me. I believe it's, on your 1040, not at the very, very bottom on the first page before you take the deductions, yeah, and the credits. I'm showing you examples of this because this is when you go to our state site, this is what it's gonna look like, but I don't like this, it's super busy, so I broke it up. Again, are you in the 0 to 80? Were you in that first one? Then if you have an energy audit and you have proposed improvements like air sealing, attic insulation, seal box insulation, dense packing your sidewalls, and you say that you can save somewhere between 20 and 34%, you're gonna get 100% of those improvements paid up to $5,000. If you can achieve 35% savings, let's say you need to air seal, your attic needs insulation, and you dense pack your sidewalls, you're probably looking at that 35% savings. If you have an older home that hasn't had many improvements and you're in this income bracket, you are lucky because this is ridiculously crazy money. There's never been that money. You're gonna have 100% of that improvement paid up to $10,000, which will likely cover almost all of it. Here's the same for like the people who are in the 80 to 150. Not as exciting, but I wouldn't turn it down. We haven't had this kind of rebate that comes straight off of this. This does not come out of your pocket. You don't get this after the fact. This comes off of the insulator's invoice. And then if you're over the 150, again, not as sweet, but it's way sweeter than it used to be. That's what's called the Inflation Reduction Act, or IRA homes program. Because a lot of the improvements are about the home, the shell, the insulation. You can model a few other things like appliance upgrades, but it's mainly about insulation. The other program is called HERE, Home Electrification and Appliance Rebate. This is all about helping people do exactly what we're talking about, changing to that heat pump technology. I also don't like this chart, it's too busy, so I use this one, but I want you to see what it's gonna look like when you go to the website, so you're like, hey, I remember that. If you're over the 150, even though homes had a little bit for you, HERE's not gonna have anything for you, I'm really sorry. But if you're under the 150, you're looking at, if you're the 0 to 80, you're gonna have 100% of these costs covered up to this number, okay? So you buy a heat pump, they're gonna cover 100% up to 8,000. You need a new breaker box because of one of these improvements, 4,000 covered. Now, if you're in that second income, the 80 to 150, you'll have 50% of this stuff paid for, but still up to these amounts. And these are a lot of numbers, but I'm gonna cruise through them. And there's a bunch of tax credits too, because I have real life examples. So this is an example of how this would play out in real life if you're in the 0 to 80. It's year one. You get an energy audit. It's free. It's covered by the IRA. You decide, well, I'm gonna do air sealing and attic insulation. Let's just say that's the only thing your house needs. But let's say that it achieves at least that 20% savings. That means you're gonna get homes. You're gonna get the homes IRA. You're gonna get 50%, or I'm sorry, you're gonna get 100% up to that 10,000, but you only had to spend 4. And you don't even spend the 4 because it costs 4. You subtract out your state. You then take 50% of that and homes covers. So your out of pocket is actually 0. Year 2, your water heater dies and you're like, I'm gonna go with a heat pump water heater. But the electrician says, well, you need a panel upgrade and we gotta add some wiring. Well, guess what? If you're in the 0 to 80, here is gonna cover all of the electrical panel. This is a big disclaimer. I've estimated these costs. I've asked around. It's gonna be different for everybody, but just for an example's sake, I'm using these, I'm using example costs just to be really clear. Your electrical wiring is gonna be completely covered, and your heat pump water heater that was $4 grand is actually only gonna end up costing you $1,950. So half. The next year after that, your AC dies, or your furnace dies, or you just say, you know what? I want to start electrifying my house. So you buy the heat pump, but you say, you know what? I don't want to give up my furnace. It's my safety blanket. It's something I've had forever. I want it. I mean, how many polar vortexes are left? Probably a few. We need it to do the heavy lifting. So you get a bid. It's around 14 grand, but you get this for the state. You get this from here. So out of pocket is that, but you're also going to get a tax credit. You've just maxed out all of your here rebates. So in this example, I don't have them doing the heat pump dryer or the induction cooktop because I just wanted to show what happens when you take advantage of these. Because remember the here, you can only get up to 14,000. This household took advantage of that and maxed that out. Here's your state rebates. Here's another federal homes rebate. Here's a tax credit. And this is the discount you get. So you can get $27,000 worth, this is approximate, of work for about $5,500. That's like somebody handing you a coupon for 80% off. That's astounding. This money will not be around long. That's why my examples are about 5 years. You have to move and shake. This is if you're in the 80 to 150, same exact scenario. Year 1, audit, air sealing, attic insulation. Year 2, the water heater dies. You get your electrical panel upgraded if you need to, and you get some electrical wiring done. Then you get the heat pump and the furnace combo. And in this case, you can actually take advantage of the here and get the heat pump dryer and the induction cooktop. And so here, you're looking at $29,000 value for about 10. And somebody's handing you a coupon saying, here's your 63% off. And this, and this, and this does not come out of your pocket. It comes right off of the invoice. This is the only thing, the tax credit, that you actually have to have a tax liability for, right? So that doesn't end up coming off of the invoice, just off of your taxes. Again, have never seen this kind of discount. Now, if you're in that over 150, it's still not looking bad because I don't know about you, but I will cut out a coupon when it says 25% off. And I will go and make my purchase because I can save 25% off. I don't care if it's dog food or a heat pump, I'm saving 25%. So this is nothing to sneeze at either. And you'll see they don't get anything from the here, very minimal from homes, about the same from state, but your tax credit just increases because you're paying more out of pocket, and that's what the tax credit is based off of. This last example is if you are in the 0 to 80 and you have an older home, and so you actually do everything. You air seal, you insulate your attic, you dense pack your sidewalls, and you insulate your sill box. So you get over that 35%. All of that will cost, like, well, what do I got here? $9, $10, $11,000. But you're gonna get this from our state rebate. And then you're gonna get this from homes, and you're not gonna pay anything. So if you have an older home and you're in 0 to 80, like, it is your time to shine. It is time to make this happen. And this was the same exact example that I showed before, only I added in 2 more upgrades, which kicked them up into like the higher, you know, that like 100% back up to 10,000. So look at what their discount is, 88%. So a lot of information, right? How do you find all this stuff?
Laura,
Yeah,
can I give you a chance to catch your breath just for a minute?
yeah.
And how we doing? How we doing? I'm gonna do a time check. 8:06. Everybody's still here? You haven't fallen asleep? The pizza hasn't put you to sleep yet? You're gonna get graduate level coursework accreditation for tonight's attendance at this meeting, okay? Laura is about to dive into some, if you can hang with us, we're gonna go to some live websites. You're gonna see Laura go to the Focus on Energy website, go to the IRA Homes website, and so on and so on. Don't worry about keeping track of what website she's on. I'm gonna hand out a cheat sheet with links to all the websites, so pass that around. And then if you want an email with a copy of that document, so you'll have live hot links to all those websites.
That you can just click on,
You
right?
just click on that and it'll go directly to the Homes website or directly to the Inflation Reduction Act website. Please add your name and your email address and we'll send you a copy of that document, all right? Question.
I like more of a comment before and I don't want to take too much time. In Shorewood Hills, we have 2 National Historic Districts. The state of Wisconsin, if you're approved for capital improvements to your home, you can get a 25% project credit on your Wisconsin state taxes. So to find out if your house is a contributing home to the National Historic Districts in the village, just Google your address and put in Wisconsin Historical Society. They'll have, if your home is contributing, it'll say yes or no. You have to fill out 2 pages of paperwork and take it down to the Historical Society. You can go to the terrace and have a beer. And you have to get photos, but you can print out real photos at Walgreens from your phone using the app. I mention this because you can pair all of the capital improvement to your historic home if it's contributing with these. And so then that adds on top of it. And I've already done this with an HVAC project last year, but I mention it because it's something that I don't know if most people are aware of the Wisconsin State Historical Society tax credit. You have to send in the paperwork when it's done, but it's up to 25%. It's 25% of the project, up to $40,000.
Wow.
So it's $10,000 for any single project, but the project could be insulation, it could be plumbing, it could be HVAC.
Wow.
Solar panels too, but you have to conform to their specifications. But it takes those numbers that you put up and makes things free or more than free if you can just do a couple extra paperwork things. So
That's
like
awesome.
to mention that.
Thank you. Yeah. So like, where is all this stuff? Well, I'm gonna hop through a few things just so like when you get on the websites, you're like, oh, hey, I remember that. And every page that I'm gonna go through here is add a link there. But this is the main page. This is what it looks like. IRA home energy rebates are rolling out. You'll see that they have the homes. So that's the one that I talked about. There's 2 programs, homes and here. Here is not yet available, but like any minute, they're like any minute. Homes is the one where I said like, well, anyway, if you click on learn more for homes, it takes you to this. This is the one where I showed you, but I said like, oh, this is too messy, I don't like it. And then I just remember it was it's the, you have an energy audit, you get it modeled, you have to prove like 20 to 34% savings or 35. But this is the one where if you're in the 0 to 80 and you can get 35% savings from like proposed improvements, that's where you get up to the 10,000. So that's homes, okay? Then if you, here is on this same main page and you would click on that and then it ends up taking you to this, which we saw this chart too. And I was like, I don't like that one. It's too busy. But this is the one where people get up to $14,000 and it's all about the heat pump stuff, including the breaker panel and the wiring that might need to happen. And then the induction cooktop. There is a small portion of insulation and air sealing rewards through here. This would be for like, you can't double dip. So you can't like get homes, you can't get like 10 grand from homes and then get 1,600 from here. This is if you have an audit or you just know like, I'm not gonna be able to achieve 20% savings. Like you have some improvements you need to do, maybe top off your attic insulation, maybe get a few, I don't know if windows are, let's say you just need to do a few, like your sill box and maybe like your attic, but it's not gonna get you the 20% savings that's necessary. You can still get like, either 50% or 100% up to that. So we've got homes, we've got here. The other really handy thing is here on this main page, you see this get started right here. When you click on that, it takes you to this awesome residential rebate finder where you can put in your information, which I did. I put in Shorewoods right here and I just said the household makes, I said it's household 2 and they make $10,000. And then I hit search.
10,000?
I'm sorry, 100,000. Sorry, yeah, 100,000. And it'll give you all the rebates available. And you can even say like, just show me insulation or like, just show me appliances, right? So it'll show you like the dryer and the cooktop, or it's like, show me water heating. And it'll give you everything that's available from our state and federal and tax credit, all the rebates. So it's super handy. Or you can just say like, show me everything. And that's when you get all of these. This is very helpful. There's a link on that page that on the printout. The other thing I want to show you is what happens is when you start this journey, you're going to see this customer journey image. It's going to say income qualification. Because you heard me say that all of these are based off of your income. So somebody's got to check your income. How do you do that? You scroll down and you say, I'm ready to get started. You click on that, and what's going to happen is you're going to put in some very basic information and hit continue. And then it's going to then either ask you for or send you an email saying, hey, we got your information. You need to supply us with XYZ. Like you're going to actually have to send us your income verification. And this is through Focus on Energy, who is our state and federal IRA people. They will then take your verification documents over email. And then about a week later, you're going to get an email that says, based off of your income, here's what you're eligible for. They'll probably say, this is the level that you're eligible for. So you go on this main site, you get income verified. You could do this right now, right? And then what's the very next thing you're going to do? You're going to start looking for contractors. How do you do that? There's a great tool. It's at that link. You're going to start searching for contractors. You put in your zip code. Just using this one as an example, Accurate, Airtight, they've been around forever in Madison. But what happens
Laura?
is, yeah.
Can we use any contractor?
You cannot use any contractor. You have to use an IRA contractor. How do you find them? I've provided you the link, or you can come to the main Focus on Energy website and you can look up right here under resources, find a Find a trade ally contractor. Let me make sure actually that this is not our state. Wow, it's wanting to be slow. But what you should get to is this, find a contractor.
And the reason that's important, it could develop to be the wild, wild west out there with, you know, people knocking on your door saying, I can insulate and so on. You might not want to do business with them until you make sure that they're a Focus on Energy trade ally. They've taken a sworn oath with Focus on Energy, and Focus on Energy has kind of authenticated them.
And when I showed you to go up to here to resources to find a trade ally, I'm actually kind of incorrect. This, and it says it right here, because before we had IRA, people were just state trade allies, but it says right here, hey, are you looking for an IRA? You know, you can click, it'll take you to the right search tool for just IRA contractors, which is what I was on here. And when you click on these people, it's gonna tell you, because it gets a little complicated. Remember, there's here, okay, these guys do here. They're also a homes, and they're also what's called a primary contractor. Everybody's gonna kind of need to have a primary contractor if you're gonna do multiple upgrades, meaning if you're gonna do homes and here, and say something else, like Focus is saying, IRA is saying you need to use this primary contractor because they're gonna really help you like streamline everything. And so that's how they've set it up. And I believe they help you like get bids for everything and kind of like help you through the process. I've heard they can even help you get income qualified, but I would just use the income qualification site. If this is all super confusing, you can actually come here again to the resources energy advisor map, and there are IRA homes energy advisors in our area. It is Jason Kempen. If you are interested in IRA here, but you're confused, it looks like our area is Scott Saylor. So you can contact these people if you have questions, and if I'm not available, because you can also call me at MGE. The state rebates are all here too, and that's on there, okay, for like from our Focus on Energy state. And then finally tax credits, and that's at a link too, and all the tax credits are listed here, all the details about each one. But believe it or not, I'm done. So we've made it through, and I'm still standing. But it's a lot, and really the main takeaway is like, get excited, get motivated, don't waste time. Figure out if you think your house might need enough improvements that it's worth getting an energy audit. If you're in the 0 to 80, it's free, so you don't have to worry about it. If you're in that 80 to 150, if you're in the above 80, you can call me. Or even some of these contractors are gonna start getting a pretty good idea, like, tell me about your house, right? Like, they'll probably say like, ugh, maybe not worth it for you, probably won't get the 20%, or, you know, looks good, or just get the energy audit, and then you have an idea, you know? But we're here to help. I mean, this is so much to navigate, right? But it's also so exciting. So that's all I really want you to do, is just get excited about using energy efficiently, bring on renewables in whatever way makes sense for you, either through one of our programs, your own solar, or just waiting for our grid to decarbonize, which is happening, and then electrify everything and feel okay about it. It's kind of scary. Before, when you had to make a choice, it was the same choice you've made for the last 60 years. Natural gas furnace, sure, give me the most efficient one, right? Now it's like, oh, wait, what? Heat pumps? Oh, I don't know. But it's okay. We're all moving in this direction and we're gonna do it together. And it's really our buildings that are the next necessary step to decarbonize and combat global warming. So, thanks. And now I'll take questions.
Just like a practical thing, you said if you come off the invoice. From the actual bill, right? So what's the actual steps to get the contractor to know what you bought?
You have the audit.
You
You have to get income qualified.
You all,
You get income qualified through that, right? And then you go to the IRA contractor search tool and you pick a contractor. And you make sure they're a primary contractor, right? And then they'll know, because after you're income verified, you'll know, you'll know this is like the level you're eligible
you're
for.
qualified, then they can take it off.
Yep, and then they're gonna take it off, right off the bill, and they're getting paid through back end.
Okay.
Yeah, IRS stuff.
All right.
Yeah.
Thanks.
So are the home energy audits free or only in certain categories?
The home energy audit is free only if you're in the 0 to 80 income bracket.
Okay,
If you're in this income bracket, they're free.
and if you're not, then what?
If you're not, they're about $500.
Okay. Oh,
And you know what? If you have a home energy audit and you've never had one before and you spend the money, it's a great value. Even if you figure out, I can't model and save 20%, right? You still get that roadmap of everything you should do to your house, which, I mean, unless you've worked in building science and you know this stuff, like it can be hard to navigate. I mean, most people just appreciated some general idea of what are my top 5 things I should do and what's my best return on investment, you know, and that's not going to change whether you model 5% or 20% or 35%, you know, like that audit is still valuable.
Does anybody want a flyer on a home energy audit? What it's all about? What do you get from it?
does it say who to contact in here? Or?
You got to search, you got to use the search
Oh,
tool.
okay, search tool,
Yep.
okay. Okay.
Question here?
It's just the steps to get an audit.
Yep, so to get an audit, you have to search, right? And the link is in there, but you search for this. You use this IRA contractor. And it says right here, like when you click, it'll say like home energy assessments. It says like services offered, home energy assessments.
I have used airtight stickers, and they did a good job.
Yeah, they were smart to use the A.
Put it right.
Yeah. But like just as an example, like here's Becky Heating and Air Conditioning. They are a here installer. They're a home's primary contractor, but look at their services offered. They just do HVAC. So if you wanted an energy audit, you're not gonna use them. They are a primary contractor, so you do have to use a primary contractor if you're doing like multiple things. So if you for some reason trusted Bethke, you could use them as your primary contractor, right? But they only offer HVAC services. So like they'll help you navigate through this whole IRA thing. But if you know you need insulating, I might use an insulator to be my primary because I need the insulating done, you know? Any other questions?
You have an energy audit like 15 years ago when they did certain work. Does it degenerate over time or it pays to do another one or it's not?
Yeah, you could call me and we could talk about it. Like usually it does, like insulation doesn't, you know, if you had the audit and you like air sealed and you added the attic insulation and you did those things, it still should be good to go. That doesn't usually, the only time I would say that's different is if like, for some reason you had a ton of work done in your attic and like you had a bunch of rewiring something and people were trampling and moving insulation over and drilling new holes, things like that. If you had some major kind of like, you know, upgrades, then maybe, yeah. think there was another question in the back.
Same question.
Okay, yeah, and the income verification is good for a year. The audit is good for as many years as it takes. But because the income verification is only good for a year, then it's like, kind of motivated, and if you're gonna stay in the same income category, I guess it doesn't matter, right? But you could get that audit and it could take you a couple of years to get this stuff done. And I guess that's okay. I don't know exactly how that's gonna work, but mainly I would say just get it done, get everything done if you can,
You kind of mentioned about heat pump, you did a good job of explaining how you heat, but they are as efficient cooling as an air conditioner.
Better. Like when you start looking at their efficiency, like they were first invented like for cooling, and I don't know exactly why, but they are like, if you went to buy an air conditioner, like with the same efficiency that the air conditioner had, or that the heat pump had, the air conditioner would be very expensive and may not even be able to achieve the same efficiency rating as the heat pump. They're just more efficient. Like I had a woman get a heat pump and a natural gas furnace, and when I measured her like energy use over the year, she got a lot of savings from the cooling season. So that heat pump must have been much more efficient than whatever her last cooling equipment was. So yeah, they're better. So if your AC dies, you're gonna be in that position of wanting to get a heat pump, and then you're gonna have to say like, should I spend more to get one that's rated to do heating and will qualify? Because there are heat pumps that do cooling and they're not rated to do heating. Like they can, but they'll be really inefficient. And where those are helpful is like Arizona and Florida, where like maybe they'll, or not Florida, but like areas, like places where they might use the heating just a little bit, yeah.
So you're talking a lot about attics, but what if you have a house with a flat roof and there's no attic?
Yeah, I mean, then you just hope that when they constructed it, that they did a good job, and usually they did, because it's like hermetically, almost like hermetically sealed, because you probably have the rubber roof. Yeah. Those are usually pretty good. The back.
The insulation into bricks that you were talking about, so that, conceptually, that's really cool. I didn't really, you could, like, bricks, is that work stone as well?
Yeah, I mean, all materials hold heat. Some just hold it better than others, and it's all because of their properties. And those are ceramic bricks. So however ceramic is like molecularly made, it must have the ability to hold on to that heat. Yeah. In the back.
I thought of another question that, I didn't want to give up my one opportunity.
Yeah.
Following here. And I know this might be a more unusual thing, but our house was kind of built in a couple different ways. It's like 2 heating conditions.
Yeah.
Are these heat pumps able to think power? Would they able to power the whole frame? Are they that strong?
Oh, to do like both systems, like to run both systems off it? I mean, what do you have it right now? Do you have 2 outdoor condenser units? You'd probably still need 2 outdoor condenser units because their capacities are still similar, But one thing I didn't mention that's super cool about heat pumps is like, even if you have ductwork, okay, and you have a heat pump connected to that ductwork, these heat pumps can also have like refrigerant lines run separate to like say an addition that never had heat run to it because they couldn't get the ductwork there. And so let's say that room's always been like hotter or colder. You can put what's called like a wall mounted cassette head or even like a ceiling unit, and that refrigerant will run just to that little unit, and then it'll heat and cool that room where normally you wouldn't have had it. So sometimes people will have like baseboard strip heat in like a sunroom that they put on, but it's like ridiculously expensive to run. Like they turn that strip heat on and it's like crazy. I'll see it on their bill. I'm like, oh, what kind of electric space heating were you using in January? And they're like, well, we have a 3-season porch we'd really like to sit in. I'm like, okay, that would be great because you can't get ductwork there, but these heat pumps allow you to take that refrigerant and run them to like, they call them head cassettes. Or it can even be wall mounted, but it just blows the heat and cool out of it. And it's like way more efficient than electric heat, way more efficient than propane. The only place these heat pumps are still not like winning the economical battle is against natural gas. And like we've already beat that dead horse. Like it's because natural gas prices are so low. But if you have propane or electric heat, go get yourself a heat pump. Like you will come out ahead economically. Yeah.
So, the income qualification,
Yep.
is that, are there particular types of income that figure into the equation or?
There's a link to that, or you know what, I might not have put a link to that, but there is one on the website. And,
Here's the handout,
okay,
income verification process.
okay. There is a link, and where the heck was that? Let me just look really quick. I can send it to you. I don't know why I'm not finding it. It lists like all of the documentation that you could use. I'll see if I can find it. But any other questions? Okay. Well, that concludes. You guys did so good. It's 8:30. Like, who's usually in their pajamas by now? Come on, right? Okay.
Thanks to the
Seriously.
Village Green Team for the invitation. Your graduate level 401 coursework accreditation, pieces of parchment paper will be available by mail in 10 days. Nate, any final words? Katie?
Okay, thank you guys, thank you, Laura.
Yeah, of course.
Thanks everyone for coming. Thanks.
Yeah, thank you. Is that okay?